Okay, so I guess this is the last of the formal lectures for me anyway, and this lecture is going to be a bit shorter because I've only got a little bit of material to go through, so it'll just be an hour, I think, rather than 2 hours. We'll see how we go with the material. So what we're going to talk about today, up until now we've talked a lot about software prototyping and some of the Arduino prototyping. What we're going to talk about today is I'm going to give you a brief introduction to physical prototyping and building real physical objects, mainly through through desktop digital fabrication and 3D printing. And then we've actually got connections through Mike into the we have access to a 3D printer in mechanical engineering. So if any of you want to try and do some real 3D printing, then you can talk to Michael and he'll set it up for you. And you can make your own objects. You were talking about making a dial that fits on top of your potentiometer, so you could use this to make some sort of dial for the project if you want to, or for anyone who wants fancy housing for something or whatever else. So sometimes in science fiction movies you see things like this. So here's what's her name? G. From Deep Space Nine. She's the captain from Deep Space Nine in the Star Trek series. But in Star Trek, they've got replicators, so you can go to a machine, say you want something, and it builds it for you. And so that's kind of the science fiction vision. But actually, we're coming fairly close to this in reality. And as you'll see as we go through today, you can get desktop replicators that are $1,000 or a little bit more than that, that will let you to do 3D printing and create 3D objects. But the background is that about 20 years ago, people started building large 3D printing machines. And there are a number of different ways you can do it. So this is a stereolithography machine. It's quite big. And so there's different methods: stereolithography, selective laser sintering, and I'll talk about that in a minute, fused layer modeling, and 3D printing. This is a typical large machine that costs lots of money. So here's another approach is to use a CNC machine. So a stereolithography machine creates 3D objects by from heating up rosin. A CNC machine carves away to produce 3D objects. So a typical CNC machine might cost you $25,000, and the stereolithography machine might cost you about $60,000 or $70,000 US. So it's quite expensive. But then you've got smaller 3D printers like this one here, which is about $15,000. But as I showed today, there's a large open source movement to build MakerBots and RepRap machines that are around about $500 to $1,000 as well. So here's kind of the evolution of the technology. Around 30 years ago, people started developing stereolithography machines, and then they moved to fused deposition modeling. And I've got a slide that talks about what those different things are. Then the first 3D printers came out. The model there is from Z Corp, which is one of the market leaders. I think they've got about a 35% market share. So if you want to have a high-end 3D print done, you can buy a Z Corp machine. And but again, it'll cost you starting around $25,000 or more, so it's quite expensive. So what stereolithography does is it has a liquid rosin, and then they use a laser to heat the rosin, and when they heat it, it solidifies. So basically, over time, you'll see a 3D object starting to emerge from a bath of liquid material. And then you slowly move down this piston, and you let the laser heat the top layer here, and it produces a 3D model. Because it's completely liquid, it means that the objects can be quite complicated, and they can be hollow inside or concave and things like that. The selective laser sintering is different. In this case, what you have is a powder, and there's two parts here. There's a piston that pushes up and pushes the powder up, and then there's a piston that goes down. So this is the delivery side, and this is the fabrication side. And then as it goes down, you have a laser beam that heats again, and it melts the powder, and it then makes a 3D object from the powder being melted. But what we're going to talk about today is mostly the low-end machines, and the low-end machines use an additive process. So it's similar. I'm not sure how many of you have done clay modeling, but in making clay pots, what people sometimes do is they'll roll long strips of clay and then start rolling it up into a size of a clay pot. So it's an additive process. So it's the same thing here. So the basic process is you start with a CAD model, and then from the CAD model you create slices from the CAD model, and then and you produce a STL model, which is a template model, and then you send that to the 3D printer. The printer then uses an additive process to deposit material on those slices, and it makes the final prototype at the end there. So this is, well, and a fourth method is a fused deposition modeling method. I should have had this slide before. In this case, you use a CNC machine that can carve away, or you can use an extruder that drops material onto it. So here's a fused deposition material. So you've got basically a print head, which is similar to a printer and a 3D to a laser printer. But as it goes along, it drops. It has a wire filament that comes down here, typically a plastic wire filament that melts in this very hot tip, and then it deposits it onto a modelling bed and makes a 3D model from that. So the tip moves in the XY plane, depositing the filament output to make the 3D content. And so this is what the typical process looks like. You start with a 3D model, you convert it into those layers like I was telling you, and then you send that to the printer, and it prints it on the maker bed, and then you can get the model from the output there. So up until about 3 or 4 years ago, most printing machines were very expensive, as I've just shown you with the stereolithography machines. But now you've had this kind of hacker movement come around, and it's produced a number of different things. So here's, for example, there's a very low-cost CNC machine. So this costs about $800 in the US to buy, and in this case, there's a drill head here, and you can carve away. And I've got a little video showing a typical CNC. Have all of you seen CNC machines working? No, none of you. Wow. Okay. I guess none of you went through mechanical engineering, but they've got a bunch of machines over there. So here's a CNC machine here. This is a high-end one, and what this one is a block of metal here, and it's going to carve it away. So let's watch that. So some really great Indian music. So you can see there it's carving away. So this is the carving head right here. And of course, because it's carving, it means that you can't necessarily create completely hollow objects. So you know, with a stereolithography, you could print a hollow ball. But with CNC, you couldn't do that. You could just produce two halves of the ball and then glue it together. So they're making a face here. But the good thing about the CNC machine, and there it's finished, is that it's you can carve quite hard materials. So this is the metal that's carving right here. You can do wood and things like that as well. Whereas with some of the other fused depositing methods, sometimes the material can be quite brittle.
Is it smoothing it?
Yeah, it's smoothing it down. So first of all, it was, Mike, in your office, don't you have the handle from the handheld display? Don't you have an old version of that? Yeah, that'd be great. Yeah. So now you can see the finished version of it carved there. So it did a rough carve, then it smoothed it out afterwards. And there's lots of examples of that, but essentially for about $800, you can build your own or buy your own CNC machine, and you can cut whatever objects you want. I was telling you about the fused depositing. When they sprayed the glue. So this is what that output from that looks like. I'll pass these around. So in this case, what they've done is this is the one I showed you before. They had the powder, and they basically spray glue onto it, and you can see it's a little bit brittle though, and the finish isn't quite as good. This is for a shoulder-mounted camera. The idea for police, the idea was that they wear a camera around all the time to film. So somebody built a CAD model of it and sent it. It's this model is about 5 years old now, so it's shrunk a little bit, so that's why it doesn't fit together exactly. But yeah. So there's a culture, I said, of this hack and kind of do-it-yourself culture, and one of the outputs from that is a project called RepRap. Have anybody heard of RepRap before? Okay, great. So RepRap is a really interesting idea. The idea was to build a low-cost 3D printer, but the interesting thing about this was that it's self-replicating. So the idea was that when you built the 3D printer, the printer could print itself, could print its own parts to make a new version of itself. And so this is what the 3D printer looks like, the RepRap looks like. And actually one of the key members of the RepRap project is a guy called Vic Oliver, who's a New Zealander here. Great. Thanks. But I thought you had the older version, the head they made as well. You have that? The white one, yeah.
Prototype.
Yeah.
Yep, it's
Yeah.
the same printer as
Yeah, but I want to show that, so that would be great, yeah. Yeah, that's, so the RepRap, as I said, it's a very low-cost 3D printer. It kind of comes in a kit set form, so you can. It's open source, so you can go onto the website. You can order. If you don't have your own 3D printer to print the pieces, you can order a bunch of pieces, and they've got the. It's driven with an Arduino board, and they've got the software as well. So I can show you more. So that's great. That's cool. Thanks. Excellent. So so you can see here's it made up, and what they've got here is the print head is right here. This is the print base, and then it's basically a mechanical frame that with some motors that drive it all around. But as I said, all the parts are printable themselves, so that's why it's called RepRap. It's a replicating rapid prototyper. Here's a smaller version. There's been, I think, there's 3 generations now. So the first generation was quite well. That was the previous one, and then this, I think, is the 3rd generation. So it's more rugged and compact. Let me show you a video of this working. So in this case, they're using a RepRap to build this kind of organic shape. And RepRap it works the same as I said before. It takes a filament of plastic wire, then it melts it, and then it adds it. It's an additive process onto the material there. And this version is I guess it's the version 3 RepRap, so that's more compact style. And you can see the lights in the front there. That's the Arduino board driving it, and there's some motors and cogs and stuff as well. And you can also modify it in some ways. So this is they call this one Rep Strap. So this guy wanted to use the same RepRap control system, but use it to do painting instead of 3D modeling. So he added some ink heads on here and use it to deposit paint rather than plastic content. However, this is the founder of another company called MakerBot, and he said basically it's not trivial to put RepRap together. It requires a lot of enthusiasm, a healthy dose of bravery, and the ability to navigate a project that is growing and changing every day. There aren't step-by-step instructions, which makes it a very challenging project. So it's really tough to build these sometimes. It takes a long time to calibrate and get it working properly. So this guy, Bray Pettis, founded another company called MakerBot. And the idea of MakerBot was to make an even easier version of a 3D printer than RepRap. And so here's the guys here. And this is the, older version of the MakerBot. And so what they have here is the MakerBot. Basically, again, it's an open source project. So if you want to, you can go and you can download all of the schematics and do it yourself, or you can contact these guys and they'll send you a kit set and you can build it yourself, or they'll even sell you complete built 3D printers. And so here's the MakerBot here. This is the first version of it. So basically it's control electronics. Again, it's based around an Arduino. And then the plastic filaments you're using to print with come through the top here. You've got the X, Y, Z axis that moves around. You have the extruder head. It's hidden up in here. And this is the build platform and the wooden frame that holds it all together. And this is the type of material it produces. So I've got a couple of examples. Well, this is a very small example. This is a bigger example. The head here was printed over in the machine over in mechanical engineering. It's not a MakerBot, but it uses the same principle. So you can pass that around. That'll give you an idea of what it looks like. And here's a very small piece of plastic they printed off the same machine. So if you want to try your own 3D printing, well, you can talk to Mike, as I said, and the finish will be a little bit about the same as that. You can sand it a little bit to make it nicer, but yeah. And this one's a little bit rough because it hasn't been sanded yet, but yeah. So this is a cupcake they made, MakerBot cupcake. Here's another version of the, well, this is the cupcake CNC machine they call it, but here's another version of the same machine. This is the print head here. So this is where the filament comes to the top, and then they have the heating element right here, and this is very, very hot. Typically gets up to, they're saying it's about 200 degrees Fahrenheit, so very, very hot. I don't know if that's in Celsius, I guess that's 100 or so Celsius, and then the liquid plastic comes out the bottom and deposits, and it builds up. So this was built in two halves, and then not the black plastic part, the white plastic part. The black plastic part was, I'm not sure, do you know, Mike, do you know what type of machine they made this on? Yeah, it's not a low-cost 3D printer, it's a high-end printer, but anyway. So this is the hot, yes, it's 200 degrees Celsius, 400 degrees Fahrenheit, so very hot. And here's the guts at the side of it here as well. And this is the spool material that you feed through it. And here it is printing ahead. So you can buy MakerBot kits, and so now, complete MakerBots. So it's about $1,000 US to buy your own MakerBot. The machine they have over in mechanical engineering is a different 3D printer that's a little bit more professional, I guess you'd say. I think that one cost around $1,500, but still not that bad. So you're almost getting to the point where you can, indeed print, some cutlery or a cup or something on your printer and take it away. I've got a little video that shows the latest version of the MakerBot working.
So models you've shown so far have had your buildings are structured within a larger structure.
Sure, yeah.
Is there one that actually can build a shape larger than itself?
No, not that I'm aware of. They all have to have the MakerBot and the RepRap. They all work by moving a print head over and depositing material. Yeah. So the print head has to be able to move over a larger volume than what you're building.
That's right. Yes.
So there have been some, and I didn't get a slide of this actually, but there have been some work where people have there is an example of people using a robot arm to build something that's larger than the robot, but the robot has to be able to move over the build volume. Yes, so what people have done though is that they'll build parts and then they'll glue the parts together to build bigger objects. So this is the new MakerBot. So the one that I showed you was the cupcake, which is a big, quite tall, and this and it has a print volume of around about this big. This one is a bit squatter and smaller. It's the latest MakerBot, and the print volume of this is about the size of a loaf of bread. So it's a bigger print volume, but the machine itself is smaller. So I'll show you this guy. And the guy who's narrating this is the CEO that had the quote before.
So you've heard about MakerBot 3D printers. You don't know what they are. Let me give you the lowdown and tell you how they work.
So this is the CEO of
MakerBot is a machine that makes you things. Whether you need things to survive in a post-apocalyptic world, or materials for your classroom, or you just want to give away some amazing things that just don't exist in the world, you can use a MakerBot to create those things. The MakerBot creation process begins with a digital design. You can either create that digital design in a 3D modeling program, or you can download one of thousands of objects from Thingiverse.com. Thingiverse.com is a universe of things. And it's one of my favorite things to do every day, to go to the site and see the new things the community has uploaded that I can make on my MakerBot. Here's the Stanford Bunny. This is a classic object that we're going to make today.
And I'll show you Thingiverse in a minute, but so you just download.
Find something you like on Thingiverse. Click on the file name and download the file to your computer. Now you've got the digital design for that object. Open up Replicator G and load in your file to Replicator G. Here, you can move it around on the platform, you can scale it to make it bigger or smaller, and then you're ready to create some G-code. G-code is an old school format that tells the machine what to do. Then you press print, and the machine jumps into life and starts making your object one layer at a time. It starts by taking the plastic that's spooled in the back and pulling it through these tubes into the extruder. The extruder heats it up and squishes it through a very teeny tiny hole, and it draws with that. It draws a picture, and then it lifts up a little bit and draws another picture. In this case, we've taken a bunny and we've sliced it up, and so it's drawing each layer of the bunny until it's complete.
So it can be quite slow. So I think these ones here took about 5 hours to print. So it's not like not like it's in the video here, but yeah, it's quite slow.
It's done. Check it out. It is a beautiful model.
Oh.
It's giant. I've seen baby bunnies that are, smaller than this. So this is can be bigger than life size. Wow, this is a great print. The MakerBot Replicator is for everyone. If you're an industrial designer or engineer, it's a no-brainer. Get one of these things and create the products of your dreams. Prototype them, produce them, and make them real. If you're a parent or teacher, please get a MakerBot Replicator and give your kids access to it. They need to be able to learn the digital design skills so that they can solve the problems of the next generation. If you're an ordinary person who just wants to live in the future, get a MakerBot and hold the whole world in your hands.
So what was your question, sorry?
Oh, so I was just sort of wondering about how, the plastic that's already printed, and then when they go to print on top of it, it might have already sort of set, and the adhesion between them.
I think that I'm not, well, I think the setting process is quite slow, so I think it's not a problem. And also the plastic you're depositing is really hot, so it might remelt things. So let's just see what the price, I can't remember what the price is, so let's visit MakerBot and we'll find out what the prices of this new thing is. So let's see products. Okay, so this looks like wow, it's quite a long lead time, but they're selling it now for $1,700. That's the new one that you shot the video of, and it looks like it's a 10-week lead time. And they have all these other bits and pieces. So you can build, if you want to, you can buy your own motherboard, and you can buy your own pieces, and build your own system from scratch if you want to. So as I said, because it's open source, you can download the plans and build it yourself too.
Sorry, just down the bottom of the page, on the left, you had the price of the actual spool.
Yeah, it's $90 for the material, and that's a 1 kg spool. So I guess I'm not sure if there's other places selling material at different prices, but yeah, that's it. Yeah, and you can get coloured plastic as well. So yeah. Anyway, that's the MakerBot. We've got some parts here. This is a radio-controlled car, which they printed. It's $90, but it's all printed on the MakerBot with, and it's got all the electronics and everything in it as well. And there's a bunch of other stuff too. I guess there's the old Thingomatic. I think is the old version, or not? No, that's not it. This is the old one, the CNC, Cupcake CNC. Yeah. Anyway, so that's MakerBot, and there's other options as well. So this is another one called Fab at Home, and this is a little more expensive, and it has a little bit different process. This is $2,500. And then there's also these guys are kind of interesting, called Candy Fab. What they do is they have sugar, and they make models out of sugar. So you can, because sugar's really fine powder, so you just have to heat the sugar, and it melts and solidifies. So they can make some quite complicated models from sugar. So And this is really cheap. This is $500. Of course, it's not going to last very long compared to when it starts raining or gets wet. Then away goes your model. But if you want to do some, I guess this is the first step in doing some prototyping. You can build a rough object, and that's kind of what we did with the handheld displays here. We used the 3D printer over in mechanical engineering to build the white form there, and then when we've tuned the CAD model to the point that all the pieces fit together, then we sent out and built these halves that were done on a different type of 3D molding machine. So over the last few years, the quality has been evolving as well. So this is actually somebody's making some pieces for a Monopoly game, I think, and this is the quality of output that came from a Stratasys machine. It's €20,000 machine, so about $40,000. And this is the same piece done on a RepRap, which is €400, so $800 or so. And over time, the RepRap output has been improving as well. So this is 2006, you had a piece like this, and then now you get in 2008, 2 years later, you've got a piece that's very, very smooth, as you can see from here. So I could imagine that, well, it's about $2,000 now to get a 3D printer, and I could imagine that within the next 5 years, the cost will come down to $1,000 or even sub $1,000, and eventually it'll be the same as desktop printers, where you basically pay $100 or so, you buy yourself a desktop printer, and actually most of the cost is in the medium you're putting into the printer. Every time I get a set of new cartridges from my printer, it's about $70, and so that's almost as expensive as the printer itself. So that's the making the 3D objects, but then of course the other part is actually making the 3D model that you're going to print itself. And there's a number of ways to do that. So there are a number of different low-cost or free software applications that you build 3D models. So Google SketchUp, Blender, or OpenSCAD. So one of them is FreeCAD. It's a free CAD software. And the main thing is that once you've made the 3D model is that these 3D printers take objects in the STL format. STL is a simple text format that specifies those layers that to be printed on. So Google with their Google SketchUp, they made it. I mean, it's a very nice free piece of software that you can generate STLs as well. So it makes it very, very easy. So here's a typical process where you go through and you make the model, and then you take your STL file and you create those layers. So here's the layers. If you've got sharp eyes, you can see the layers appearing there. Then you use the G-code they're saying for, and what the G-code does is that's the commands used by the MakerBot to actually drive the head. You'll see the interface looks very familiar. This is the same GUI as processing. So again, because it's open source, they could take the processing GUI and they could reproduce that and use it to drive their software. And then from that, you send it to the printer and it starts printing out on here. And then is your whistle that you've made finally. There you go. So another approach, though, is to use online services. So you may not have your own 3D printer. So if you can make a 3D model, then you can upload it and other people will do the printing for you. Or you can even go to online repositories of 3D objects, and you can download the objects and then print them if you've got your own printer as well. So one of the interesting ones is this company called My3D Scanner. And what My3D Scanner does is they make 3D models from photographs. So let's go to their website, and you can see. So you could take multiple photographs. You upload the photographs to their site, and then it'll from the pictures it'll generate a 3D model. And then if you want to, you could then take the 3D model and send it to a 3D printer, and you could print it. So like it says, here's your camera or mobile phone is already a 3D scanner. So for example, if Rory wanted to make a 3D model of his face, somebody could take multiple photographs of his face, then they could upload the photographs to the service. These guys have a server that uses computer vision processing to stitch the photographs together and make a 3D model from it, and then you can download from them the 3D CAD file. Then you can convert it to an STL, and then you can print it, and then you've got a model of your face, which is great. Yeah. So so you basically create an account, and then you can go through and upload to the account here, and you can download your projects. Here's some samples of what they've done. What they do also though is they've so these are different 3D objects, but actually they provide these as 3D PDFs. So I'll show you some of the PDFs they've got.
Does it cost anything?
Yes, I'm not sure what the pricing is. Yeah, I didn't look into pricing, but there's also some free options as well. So it's typical this model. So I can open this up in Adobe, and so here's a model of some angels. Click on it. Let me rotate it around this 3D model there. So they've taken maybe from a tombstone or something, and that's the whole model, but I can view it as a wireframe object. Well, it's quite dense, but you can see there's all the polygons being generated from the model, and you can look at the back side as well. Or so is this one here was a doorknob. A little bit dark, isn't it? But I think I can go. If I click on that, it'll put it into 3D. And again, I can go down to the solid view here. So this is now, it's a smaller model, so it's much faster. So somebody has gone and taken a photograph of a old doorknob on a building or something. And then you can upload the photographs, and again, you can generate 3D geometry from that. And the last one is this one here, which I think, yeah, it's like a lintel or something from an old house. And you can see it captures the texture as well as the geometry, so it's quite nice. And then again, you can go to the see the wireframe view, different views as well. Shaded illustration. Oh, that's cool. So yeah. So we're not going to have any more assignments, but if I were to set an assignment, I'd set an assignment where you had to use your cell phone to take pictures of something, upload them to this, and then generate a 3D model from the pictures. Yeah, so that's my 3D scanner. I think there's a video here. Oh, so it says it generates the point cloud for free, so yeah. Make 3D scans for free. So I'm not quite sure what the business model is. It may be that they generate the models, but they don't. If you pay more money, you get a higher resolution model or whatever. But anyway, it's the starting point. And where is the power? Okay. There are also other options. This is a company called Pinocchio. Has anybody heard of Pinocchio? Probably not. So Pinocchio is actually a New Zealand company, and they it's a design website where you can download other people's designs, or you can upload your own design. So if you design an interesting like some furniture, for example, that could be cut on a CNC machine, you can upload the models to their site, and you can sell your plans, and then somebody can buy your plans and then put it to their CNC machine and build a piece of furniture. Or, and as I said, they've got 3D objects as well. So let's look at their website and see this. So this is, as I said, it's a New Zealand company, but they've got a site in the States as well, and you can buy or sell things. So if you go to the buy place, so here's a number of objects that they've got, and if you want, you can either buy the plans, or they'll print the object for you as well. So for example, here's a folding ukulele, and this is kind of expensive. They're selling this one for It looks like it's $250 US, so it's quite expensive. But I guess the ukulele all folds up into a little box, so you can see. It's folded up, and there it is, kind of unfolding. And here is the final version like that. So this is all laser cut. So if you want that, then you say, oh, I want that. So it's 6 weeks for construction delivery. So you buy it, and then they will ship it to you. They'll do the laser cutting themselves, and they'll ship it to you, all pre-built. But other people are using on the site. They're selling plans. So for example, here's a tie hanger. So I guess it's a hanger with slots, so you can put your ties in the slots. And if you want this one, it's a free object. So you click on it, and it'll give you the CNC file for free. And if you've got a laser cutter, you can then cut it yourself. Obviously, it's a very simple object. That's why it's free. But yeah, you can add to your personal factory, and in your personal factory, then they'll make it for you, or you can download the pattern and do it yourself. There's a Cell website. So in the Cell site, you can upload your own products and sell them as well. And then there's also a Make site, and the Make site is where they'll make stuff for you. And they had a pricing. Oh, here's the pricing here. So, so here's the. They have two models. You can become a Prime member where you pay $40 a month, and then you can do a whole bunch of stuff, or you can just use it without that. And so here's some of the costs here. So, if you want to do 3D printing, they say that they charge 80 cents a cubic centimeter. So I don't know how big these objects are, but you know, that might be 20 cubic centimeters or something, so it might be 15 or 16 bucks to print that white piece right there. And they also do laser cutting as well, and they charge by the minute for that. It's hard to know how long it takes to print an object, but they're charging $2 a minute from that one as well. So if you don't have your own 3D printer, then you can use a service like this to do the printing just for yourself. There's other companies like that as well. And the nice thing about Pinocchio also is that if you are a designer, you can make your own designs, and they'll market them and sell them for you. Or if you want to, from your website, you know, have your design, have a link back to Pinocchio, and somebody can buy your design from them, and you don't have to worry about printing it or making it or anything like that. So it's a nice factory. There's Google Warehouse as well. So with Google Warehouse, again, you can download 3D models, and if they're in the STL format, then you can print them already. There's this other one called Thingiverse, and Thingiverse was done by the guys who made MakerBot. So when they made MakerBot, they realized that there wasn't a 3D website where you could get 3D models. So they created Thingiverse, and Thingiverse is like a Wikipedia of 3D objects. So we can go and look at Thingiverse. And here's Thingiverse here. Okay, so let's go back home, start this. So on the Thingiverse homepage, you can then download 3D models of different objects. And all the 3D models here can be printed on a MakerBot. So let's search for something. Let's search for Star Wars, and we'll see what they've got in the Star Wars area. Okay, so here's a Star Wars versus Star Trek chess set. So I guess they have the Star Wars and the Rebel Alliance logo, and the other one is the Star Trek logo. And then if you download this, it's a 1 meg file. It'll give you the STL file for printing this. So, and there's no cost for that. So it's a little bit different from Pinocchio. There's also, this is pretty cool. This is a land speeder, but actually, I don't know if this is actually an STL file or if it's somebody tried to looks pretty rough. Yeah, it's a PLY file, so maybe it's not. So they use the MHIT 3D scanner to build a point cloud, but it doesn't look like it's quite complete. But there's other objects, so if you go down a little bit, here's the Han Solo in Carbonite. So if you want to build your own version of Han Solo in Carbonite, you can download the file from here, and then again you can print it on your 3D printer. So, and I think, yes, here's the STL file for that. So that's what that looks like there. And I said it's all free. Let's look at something more complicated. Maybe we'll look for a. Does anybody have an idea for a model you want to look at? Name an object.
Hard hit.
Hard hit. Okay. Oh, that's kind of boring, but okay. Whatever. Let's see. There's no hard hits. Okay. Let's see. Okay, spiders. Okay, so there's a spider ring, there's a big spider, there's a Lego spider. I guess you can print out the arms and they plug into a Lego Mindstorms. There's another 8-legged big spider with a car, a spider pendant. Yeah, lots of stuff. Let's look for, see if we've got any tank. There's some 3 models of tanks. Oh, yeah, there's some tanks here. Oh, here's a tank you can print and put a webcam on. Tank belts. Yeah, so you can see. You can print out all the tracks and everything. So lots of stuff. So if you have your MakerBot and then you know as the guy said you feel a desire to build a spider or build a tank, you can just browse through here and then you can. And it's a little bit like Pinocchio too, is you can upload your own file and everything as well. So here's a different, a flushable toilet, so a ball maze, lots of different things. So the corollary, I said, is Wikipedia. So Wikipedia is a repository of knowledge, YouTube is a repository of entertainment, and Thingiverse is a repository of 3D things. And they're all user-generated, and they all can be printed on MakerBots or something else, take STL files. Here's a guy who had some examples of output. So this is a guy whose children had a toy train, and I guess they needed another slot part to go in here, and so he printed it himself rather than going and buying it. Here's a toy that somebody's made, a articulated object. Here's a model of a cathedral. It's quite big, so they had to build it in pieces. But again, this is on Thingiverse as well, so if you want to go and download a Gothic cathedral and print it, you can print this, and then you've got to have to glue all the pieces together to make the final model.
I'd imagine this sort of technology would be really good for like architectural.
Yeah, definitely. Architecture. Well, other examples is in biomedical. So if somebody has to have a plate put in their head, sometimes what they'll do is they'll scan the head, and then you might want to create a 3D model of the skull and with the hole cut out of it, and then they can test to make sure the plate fits. The guys over in mechanical engineering are using their 3D printer to build artificial joints. So here's some other examples here. Some people make a clip, some ball bearings, a handle that clips onto their the power cable for their iMac, nut and bolt, glasses, whatever you want really. This is a guy who built an attachment for his MakerBot, and some other pieces that are on the MakerBot. And there's another company as well called Shapeways, and Shapeways is basically same as Thingiverse. It also lets you download 3D files and then print them as well. The other thing, so what companies like Pinocchio let you do is also customize the model as well. So you can, using Shapeways or Pinocchio, you can pick the model you want, and then you can customize it by changing the color or changing the material, and then you can upload it back to Pinocchio and then order it and get it 3D printed. And so what are people doing with it? Well, here's some other examples of what people have done. So here's, it's often used for enclosures, and as if we had more time in the course and had one more week, or if I'd moved the assignments around, the idea was for the final assignment was to use a 3D printer to make an enclosure for either an Arduino board or some of your sensors or controllers, and then print them out. But here's an enclosure. Here's somebody who's made a case for their iPhone. Here's somebody who's, well, has made some toys. This guy made a stand for his iPad, and he's made a geodesic dome construction set. So all the little connectors are all printed on 3D printer. Yeah, some shoe models, a lighter, lots of different stuff basically. Yeah. And it continues. So here's some, well, I said the sugar printer is one of the more recent ones as well. This is the commercial system. Actually, I think this is the system they have. Does this look like the printer they've got in mechanical engineering? This is one they've got there. It's a 3D printer. And this one costs about $3,000 US. I guess partly because it's a bit more professional and more rugged than some of the MakerBot stuff. But it's so this is what they've got over in mechanical engineering. So if any of you want to try, then all you've got to do is build an STL file, and then talk to Mike, and he can take you over, and they'll print the stuff for you over there. Did they say we have to pay for it, or what was the deal? Yeah, it's not really heavily used. I mean, I think if you're building small objects, if you start building a big, like a Lego set or something, they might start getting a bit stroppy. But if you want to build a small object, then it's fine. And again, this is kind of the process you go through. So here's here's one type of workflow process. So the outcome is to build some sort of STL file. And so what you could do is you go to Thingiverse. You could download a file from Thingiverse, like or from the Google Warehouse. You bring it into SketchUp. You could modify it a little bit, add some features, change the size, and then take it to MeshLab, which will then create the STL file, which then you can print. If you want to, you can upload it again to Thingiverse. Another path is to use Art of Illusion. So Art of Illusion is another free 3D modeling software. And then you can model Art of Illusion and then again generate the STL file and then print it as well. And so that was all I was going to say today. Here's some more URLs. I'll upload these to the course website. In fact, I just realised I didn't upload the lectures from last week either yet, so I'll upload them both as well. So do you have any questions about building 3D objects? And we don't have time, but if we'd had another lecture, then I would have had more content talking more about the design principles. But obviously, people do whole courses on industrial design to actually do the design of the objects. But the hope is this gives you a little taste, and then if any of you are interested, you're more than welcome, as I said, to work with Michael, and he can have you. You can build a model, and then the guys will take it over there and print it as well. It's very, very super easy to do. And so for the assignment, if you wanted to build a custom control, like you could imagine, you've got a potentiometer to control the tilt of the cannon. If you wanted to, you could build a 3D model of the cannon, and you could stick it on the potentiometer so that people could turn the cannon around to change the tilt, for example. It'd be very, very easy. So any questions at all?
Question of the assignment.
Sure, yeah. And actually, what we're going to do for the lab this week, and we'll still run a lab on Friday, and Michael's going to work with you on Friday on the assignments as well. So you guys can use the lab time to start. But yeah, what was your question?